Enterprise networks are currently dealing with a massive, unmonitored surge in the adoption of generative AI tools by their own internal teams. This unchecked sprawl, often called shadow AI, is an active hemorrhage of corporate assets, currently driving up data breach costs by an average of $670,000 per incident. To counter this, many security teams deploy niche AI exposure scanners. These specific tools are highly effective at discovering misconfigured AI APIs and exposed vector databases, which are the specialized storage systems used for AI memory. However, they treat every discovered endpoint as an isolated IT problem, completely disconnected from the broader network. This technical document outlines a crucial limitation in that scanning strategy, specifically highlighting the difference between inbound and outbound shadow AI. Niche tools can map inbound risks, like forgotten cloud storage spun up by developers on public IPs, but they are completely blind to outbound risks, like an employee quietly pasting sensitive source code into the public web interface of ChatGPT. No external scanner can see that. It requires internal endpoint agents to detect. Relying entirely on external AI scanners introduces a massive operational burden known as the false positive tax. Finding an exposed AI database on a shared public IP is like finding an unlabeled jar left on a shared corporate kitchen counter. Your highly trained security analysts are forced to waste hours playing detective just to figure out if the asset actually belongs to your organization or a neighbor. An isolated discovery tool acts like a state-of-the-art sensor designed exclusively to tell you if a single window to your AI laboratory is unlocked. That is valuable information. But if the front door is wide open and the back of the house is on fire, knowing the status of that one window doesn't save you. You have to see exactly how an attacker plans to navigate the rest of your digital perimeter. Finding an exposed AI asset provides very little value without irrefutable business context. Security operations centers are already drowning in a deluge of false positive alerts. They require absolute, undeniable certainty about what they are looking at and why it matters. ThreatNG approaches this entire problem differently, using a zero-connector reconnaissance model. Instead of relying on internal agents, it maps your true external attack surface exactly as an attacker does, from the outside looking in. Because it operates purely externally, there is zero deployment friction. It requires no API keys, no read access permissions needed, and it bypasses internal approvals required to install new agents. To eliminate the manual detective work required by other tools, ThreatNG applies legal-grade attribution. It automatically extracts metadata to provide deterministic proof of exactly who owns the asset. This forensic evidence is attached to the threat before it hits a security desk, bypassing the manual triage bottleneck entirely. Establishing undeniable ownership from the outside in is the mandatory first step in threat resolution. You cannot accurately evaluate the real-world risk of an exposed asset until you have absolute certainty about who controls it. An organization's true AI risk surface extends deep into the digital supply chain. Because these networks are interconnected, a vulnerability in a third-party partner's environment creates a direct path into your proprietary data. Niche scanners restrict their view to your internal assets, but if a third-party partner, like your external HR vendor, leaves an AI-powered database exposed, your proprietary data is suddenly up for grabs, and internal tools will never see it coming. Referencing the visual, looking at this competitive capability matrix, the row detailing third-party risk management illustrates how ThreatNG solves this blind spot. Using tri-fold discovery, the platform actively maps your supply chain to uncover hidden AI infrastructure belonging to your vendors. ThreatNG correlates technical AI flaws against non-technical business indicators using its DAR chain methodology and sentiment module. It cross-references an exposed API against real-world distress signals, tracking whether that vendor is facing a lawsuit or negative SEC filing. By fusing technical vulnerabilities with conversational risk, the platform constructs a highly structured threat model, isolating specific attack choke points. Correlating isolated technical flaws with real-world business distress reveals an attacker's true intent. It takes raw, seemingly unrelated data points and transforms them into actionable strategic intelligence. An exposed AI API flagged in a vacuum is a routine IT alert. A technician files a ticket, assigns a standard CVSS score, and puts it in a queue to be patched eventually. This final row on the matrix, covering business and legal context, shows how that baseline changes entirely. If that same exposed AI API belongs to a vendor that just executed a massive workforce layoff and currently has credentials leaking on the dark web, the situation is an immediate business emergency. That context allows security teams to intervene proactively. Contextual certainty allows security leaders to move past reactive patching and execute a strategic, continuous threat exposure management program. By integrating technical findings with business logic, the organization shifts from a state of alert fatigue to one of operational sovereignty. Autonomous adversaries execute machine-speed attack chains that easily bypass isolated defenses. To outpace them, security leaders must stop treating artificial intelligence as a standalone anomaly and assert absolute operational authority over their entire interconnected external attack surface.